This project introduced the fundamental concept of the GitOps workflow using ArgoCD. The main objective is to understand how application deployment and management can be fully automated and driven by a Git repository. The architecture flow a simple and clear flow. All Kubernetes manifests are stored in a GitHub repository, which acts as the single source of tools. ArgoCD continuously monitors this repository and synchronizes any change to Kubernetes cluster. This ensures that the cluster state always matches the design state defined in Git. For the infrastructure layer, the project can be run locally using lightweight Kubernetes environments such as Minikube or Kai, making it easy to set up and experiment without needing a cloud provider. To demonstrate the workflow, a simple engine application is deployed. The Kubernetes manifests are organized in a structured repository, separating deployment and service configurations. These manifests are then linked to an ArgoCD application resource, which enable automated synchronization between Git and cluster. Through this project, you will gain hands-on experiences with key GitOps processes, including using the ArgoCD UI, performing application synchronization, handling rollback, and understanding self-healing mechanism. By the end, you will have a solid foundation in how modern that optimized Kubernetes application using GitOps principle. This workflow describes what happens after a developer makes a change to the application. First, the developer updates the HTML code and puts it to a GitHub repository. This action automatically triggers a CI pipeline using GitHub Action. The pipeline then builds a new Docker image based on the update code and puts it to Docker Hub. After the image is successfully pushed, the pipeline updates the deployment YAML file with the new image tag. This change is committed and put back to the Git repository, ensuring that the repository always reflects the latest design state of the application. At this point, ArgoCD detects the change in the repository. It automatically synchronizes the Kubernetes cluster to match the update configuration. As part of this process, Kubernetes pulls the new Docker image and updates the running application. As a result, the application is seamlessly updated with the latest changes, completing a fully automated CI/CD and GitOps workflow. Demo flow. This demo demonstrates how to set up and run a complete GitOps workflow using ArgoCD on a local Kubernetes environment. The process starts by opening Docker desktop and launching a local cluster with Minikube. This provides a lightweight and convenient environment for running Kubernetes locally. Next, ArgoCD is installed into the cluster in a dedicated namespace. Once the installation is complete, the ArgoCD web interface is exposed using port forwarding, allowing you to access it through your browser at localhost on 8080. You can log in with the default admin user and retrieve the password directly from a Kubernetes secret. After logging in, The application is deployed by applying an ArgoCD application manifest. This step connects your Git repository to the cluster, enabling ArgoCD to continuously monitor and synchronize your application state. You can verify that everything is running correctly by checking the pod and service in the cluster. To access the application, you can either use the IP address provided by Minikube or expose the service locally using port forwarding. This allows you to view the running application in your browser. For the CI/CD setup, Docker creators are added as secret in GitHub Action. This enables automated email building and pushing whenever code changes are made. Once everything is configured, the GitOps workflow can be demonstrated. You can update the code and push it to the main branch. ArgoCD automatically detects the change, synchronizes the cluster, and updates the application without manual intervention. The demo also includes two important features. First, you can perform a rollback directly from the ArgoCD UI by selecting a previous version from the application history. Second, the self-healing capability ensures system reliability. If a pop is manually deleted, Kubernetes and ArgoCD will automatically recreate it to maintain the design state. Overall, this step-by-step flow provided a practical introduction to GitOps, showing how deployment, updates, and recovery can be fully automated in a Kubernetes environment.